let's get started.
Sounds good.
So, thanks everybody for joining. Again, I appreciate everybody who's on. Let's just remember if you could keep your phones muted, that'd be awesome. If you have questions, this is definitely meant to be interactive, so feel free to ask questions. I know, you can always ask them by also ask them by text or by chat feature, which is over here with the little people in the right-hand side. Today's webinar is going to be on the art and science of thermography for early fire detection. We will focus a little bit on waste and recycling facilities, but we'll also get into hazard materials and a number of different types of applications. And I think really, from our perspective, I know with Fire Rover, I spent a ton of time, discussing the capabilities of thermal cameras. And again, the one thing I learned early on, and I think everybody at Fire Rover learned early on, is that they're not plug and play. So it's nice to have someone who can actually break it down the way we did with lithium-ion batteries and really get back to the basics. So today I'm going to introduce Andy, instructor Andy. So basically, he will walk through. I mean, I think you guys all know my background. Um, but if you don't, we'll send this out as well, and I'll get into it a little bit more as we go. But Andy's been 27 years in the fire service. I mean, he has a lot of the level 2 thermography certified, which I think is a huge thing. And I think there's so many people out there that have a lot of questions. So Andy, I'm going to give it to you, and if you can
Okay.
go through your background and let us know, and then I'll start walking through the Fire Rover solution, specifically the waste and recycling facilities and what we're dealing with when he completes. But again, if you have questions, let me know, and feel free to send a message by chat or just you can raise your hand on here. Andy,
All right. Thank you, Ryan.
your show.
All right. Thank you. And appreciate y'all's support and attendance and your time. Your time is the most valuable thing we have. We can't buy more of it. So thank you. As Ryan says, I've been in the fire service a little while now. It feels like a minute, but it's been about 28 years now. Started in the volunteers and got into career 22 years ago. Currently serve as a battalion chief, and got into thermal imaging 10 years ago, tracing around my dad in a nonprofit applied science project called Kill the Flashover. And that's when I learned I don't know what I don't know, and literally fell into it. Was almost disabled from an injury, which put me out of work for 6 months. And while I was out, went to school and learned that the rest of the world, if they use thermal imaging, they require at least 32 hours, level 1 thermography certified, before they'll let you hold a camera. Whereas the firefighters, they just hand you a camera and say, here you go, here's how you turn it on, here's the power button. And next to the military, you have one of the most dangerous jobs with it. And that was good enough training? I don't think so. So we wrote an internationally recognized thermography-based curriculum, and that's where we got our start. You can roll on there if you have the control. I don't
Yep.
think Ryan. No. So we're going to talk about thermography. So what the heck is that fancy word? What does it mean? It's basically a non-contact remote monitoring of a heat source. And whether we like it or not, everything gives off heat. And unless you're 0 degrees Kelvin or 0 units Kelvin, which is absolute zero, they haven't found that yet, you produce energy and give off an energy signature. And it's been military technology for decades, and they've been able to use it to locate things, find things, see things they wouldn't normally do. In the fire service, we can use it to help ourselves. Like in this funny picture you see of this firefighter's head in the corner, that is an 18 or 12-inch beam of a second floor that has collapsed. That would kill firefighters, and they were able to see that before they went underneath it. If you look, you see it going diagonally downward to the left. The problem with fire service thermography is we have seconds to make an analysis, where in industry, they take a long time, or they use automated software and things we'll talk about later that can automatically give them results and data that they need. Unfortunately, firefighters don't have that, so we have to be more educated. So fire service thermography happens in seconds, where we have to interpret this data. We have to say what it means and how we apply it. And Ryan will talk more later about why it's important there's a human side of this, along with the automated side of this. So we have to have technology, but it doesn't replace a well-trained end user, if that makes sense. Go ahead, Ryan. So why is this important from the fire perspective, which we will talk about a lot today? we can locate the problem faster. We can assess priorities for corrective action. In this, which was a little video, I think it got chopped out, but you can see the edge of a door frame. All right, so there you go.
There
You
you
can
go.
pause it right there. If you look around the edges of this door frame, you'll see something known as a thermal bridge. A thermal bridge is a heat signature telling you there's something behind it. In most doors, we try to keep our heat energy and air conditioning inside, and you've got these nice little rubber gaskets that are made of flammable materials, right? What happens when it gets hot and there's a fire behind it? They burn away and produce a heat signature. So the firefighters are outside this doorway where it's relatively cool, but watch what happens when they open the door. Different perspective. He'll grab the handle here in a minute and you'll see something happen. See those little wispy marks around that? That is a pattern of a convection current as it's leaking the heat through there. That's a sign there's a problem behind that door. That's not a normal pattern. When he grabs the door, you see this puff of convection currents, heat loss. Open the door, camera shutters briefly. You see some triangles show up in the upper left-hand corner, which in this camera means low sensitivity, which low sensitivity to detail, high thermal layer, 50% of the space. That means it's hot in there, over 300 to around 1,000 degrees in some spots. That's measuring surface temperatures. This is why firefighters need this, because this occurs in zero visibility. You're allowed to see things you wouldn't normally see, like where the fire is, where the victim is, and critical factors that may hurt us. And this video came from my good friend Mike Daly, a heck of an instructor. Go ahead, Ryan. So what's the advantage of thermal detection? In the world around you, whether you know it or not, you are being monitored constantly. If you don't believe me, type in something on Google and then go to Facebook and see what pulls up about your third post. They pay search engine optimization and analytics to put whatever you search for in an ad. Well, what else is being watched is heat. Infrared monitoring is everywhere. Industry use it, military use it, medical use it. We'll talk briefly about it. But for some reason, the fire protection industry didn't really jump on board with this and realize the value of it until recently. And this side-by-side picture provided by West Virginia University, one of my instructors who does research with them, you see a couch, a nightstand, and a floor on fire in the optical view of that GoPro camera on the left. But on the right, you see so much more, don't you? And if you're an interpreter, like a language interpreter, you take whatever it is and interpret it into a language someone can understand. If you're a fire service thermography expert, you look at that and say, not only is that hot, that is ridiculously hot because the thermal layer is at the floor. So the floor could be anywhere around 300 plus degrees or greater. But if we just based it on what we see, we're missing the big picture. And Ryan's going to emphasize why we need more than just our eyes later on in the presentation. But fire, police, EMS, industry are all using this. The question is, how well are they using it? And what can we do to do better? Go ahead, Ryan. So fire thermography, if you will, is the process of acquiring this information that we would normally miss about an incident, a structure, or a fire that we wouldn't normally see, and we can assess priorities for corrective action, such as this. This is a 3-story metal training building. With the naked eye, we see next to nothing. But through proper training and interpretation, you see these weird little white spots. And those weird little white spots are thermal bridges where the metal I-beams in the structure have heated up enough to transfer the energy to the outside for the camera to say, hey, Mr. Firefighter, here's your problem, here's your sign. Now, we don't trust it 100% implicitly. When in doubt, we check it out. One of my friends and mentors, Chief Mitchum, says, but we don't use it as an exact measurement, such as some of the other cameras we'll talk about, but it's a qualitative perspective where we say, there is a problem. There is something wrong here, and we need to go and verify it and take care of it. And it allows us to do it faster, more efficiently, and more effectively. Remember that when we get later in the presentation. Faster, more effectively, and more efficiently. That's a big deal in today's world. Go ahead, Ryan. So you've probably seen a lot of people playing with drones lately. And I do mean playing, because right now I think the whole world's overwhelmed with it and the FAA can't keep up with it. But pretty soon they're going to start enforcing some rules. One of the things you see with UAV use or drones is they're using them for industry and building inspections and whatnot. But the fire services realized, hey, we can take these things and we can see things we couldn't normally see. like a wider perspective. We're looking at a house that's on fire 150 feet off the ground, and we can see the heat pattern moving from the right to the left. We can even tell you there's shingles on one side of the house, there's a tin roof on the other side. We can see the ridge vent, we can see the chimney, we can see how many firefighters are there. You're the incident commander, you're feeding that data back to your command vehicle. Your firefighters are inside and they're saying, hey, chief, we got the fire knocked down. And you see the heat signature growing across the roof line, and you properly interpret that. You say, no, I believe you need to check that attic. This is the value of thermal data. You wouldn't normally see it with your eyes, but the camera's trying to warn us and say, something's out of place here. So we can measure things, or as my dad used to say about dimming, if you can't measure it, you can't manage it. We can measure this and compare it to a baseline standard and say, there's a problem, go fix the problem, save the homeowner, save the business. We can make a difference, and we can do it better because that's what the mission's about. Go ahead, Ryan. And as you've probably seen, sadly, recently, there was a huge fire in Jacksonville, Orlando, where several firefighters were critically hurt. This was a auto liner barge full of vehicles on fire, and a drone company, one of the groups I'm involved with, they shared this photo of the drone helping them find information. So if you look at this image, you can see where they're cooling and where the rest of it is hot. So firefighting drone applications has gone as far as not only surveillance, locating heat sources, they've got drones now with water lines running to them that can go higher than aerial ladders can reach. They've got drones that do rescue that can lift up to a 300-pound victim and carry them off. They're going a lot farther with this thermal and drone research, or the applications for fire, EMS, and police. Police are using them, dispatching them to scene before the first officer gets there. And it also gives them an eye in the sky, which in this world we need all the quality oversight we can get. So that helps. Go ahead, Ryan. So how does this apply to the rest of the world? As a firefighter, I get it. I understand that I need to have this because it helps me see things that could hurt me, or it could help the victim or help the citizen. But in the rest of the world, they use it for a preventative basis, from building inspections to medical. Believe it or not, they're using it to detect cancer. You can go to veterinarian's office. They use it on an equine therapy with horses. Electrical industry is huge, big business in electrical industry. There's a company called Air One that flies high voltage power lines, like 500,000 volt power lines, and they look for breaks in the line. And these guys fly up, connect a ground wire to the line, climb out on the line and fix it. And they think we as firefighters are crazy. I said, you guys can have that job. Those guys are amazing, but they use thermography, the process of non-contact measurement, to say, there's the problem, let's fix it. Refineries, the Midwest, Texas, all those areas that have big refineries, LDAR teams or leak detection and repair teams are huge business. They use cameras like this to monitor things, condition monitoring. Manufacturers, companies that have big, expensive machines, believe it or not, words like preventive maintenance is a bad word for those companies, because if they shut down, they lose money, right? I think we all can identify with that with the last 3 months and not being able to do what we want to. Thanks to COVID-19, we probably have all lost a lot of money, but we've gained some time with our family. But the big deal of that is, if they don't have to shut down and they have some oversight, something watching for these problems, a small degree temperature increase could be a problem in a very expensive machine that they don't want to lose, such as a refinery. There are other thermal imaging cameras, like Ryan said, it's not just plug and play. There's numerous types of cameras, but there are ones that are specifically tailored for gases. Remember this, most thermal imaging cameras measure surface temperatures, not gas temperatures. If you want one that measures gases, you're looking at optical gas imaging. It's a whole different level of cameras. The lenses are about $9,000 a piece, and then you can go up to $2 million in the cameras. They're very expensive, and they're not just going to let me hold one. You got to be trained in them, and you better be insured, because if you drop that camera, it's going to hurt. So these type of cameras are used for leak detection and oil rigs and big companies that have gases that if they leak out, causes a big problem. And in Ryan's world, recycling and waste facilities, those are my firefighter friends are on board. If you've been to a recycling or waste facility fire or landfill fire, nobody raised their hand and said, yes, the cardboard facility came in today. We're going to get to fight this thing for 5 days. Nobody, where's your no fear sticker now? They don't want to be there for 5 days, right? I see somebody smiling, he gets it. You're not going to stretch an inch and 3/4 or 2.5 and knock this thing and throat punch it and be done. You're going to be there sitting on the end of an aerial with an SCBA going, "God, I'm getting overtime for this, but this sucks. What am I inhaling?" Right? So we want to stop these fires before they begin. I've been to a few of them, and they are horrible. They cause loss, they cause environmental impact, and all kind of stuff. But the point is, thermography can be used to watch over it. So much so that we just bought our first thermal imaging security system for my house. That if somebody comes down my driveway, 130 feet away, it outlines and says, "Here comes a person." Ding, 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 goes to your iPhone. You can use it for anything. We just have to be, look here, the majority of you know how to use these really well. We can do that with this too. So if we can use a smartphone, we can do this. Just take some training. Go ahead, Ryan. So you've probably seen a lot of this with the COVID stuff that's going on. It's affected tons of businesses and people, and sadly, we've lost a lot of lives. Unfortunately, we've also been fallen victims of something that the fire service and industry falls into, which is either unethical salesmanship or uneducated consumerism. We buy something without understanding what it's used for. I have counseled and talked to fire department after fire department who tried to use a thermal imaging camera that they own for the fire department to measure people for fevers or elevated body temperatures. That is not the proper use of that camera. Those cameras can be several hundred degrees off based on a numerous bunch of values that we're not going to get into today. But the ones that are used for that are specific cameras that start at about 15 grand and go up. You think they're going to give that to me and let me play with it? No. This specific camera used for elevated body temperatures, such as in airports and going across countries, they point it at the forehead and the canthus or your tear duct, and they measure it, and they give you a measurement with plus or minus half a degree Fahrenheit. That's pretty darn accurate. Now, that's a lot better than having to touch somebody with a thermometer that may be sick. That's what those are used for. By the way, they use these in looking for breast cancer, athletes that get compartment syndrome, numerous other ways they use this in the medical field, right? So it's not just search and overhaul with the fire department or you're using a camera to find overheated electrical components. Way more in depth than that. It's a multi-billion-dollar industry, and about this many people know how to properly train people and educate on it. Remember that, those of you who are looking for something to do when you retire. Go ahead, Ryan. So what's the negatives of this? There's always a contraindication. My paramedics and EMS people, or anybody who has to take a medicine, you probably hear those dreaded commercials. Hey, take this, it'll take care of this, but the side effects are death, 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 death. Great, I'm gonna take that. No, we're looking at what are the negatives to using this to help us out. Here's the first negative. You ready? Take your fingers and point them at yourself. I'm pointing at me. The problem is us. We buy something, we don't read the instructions, we don't get trained on it, we don't get educated, or as Ryan and I were talking earlier, we want about this much information and we want to go use it without getting properly trained on it, right? Just understand this. If you're going to use thermal imaging cameras, not everyone is the same. Those of you who've been in my classes before know the difference between situational awareness cameras and decision-making cameras. In Ryan's world, they're automation cameras. They're a whole different ballgame. Industrial cameras can do things that we can't even fathom, and we'll talk a little bit about that. But you have to be properly trained in it. You have to have a proper operator who interprets the data. Like if you teach we were talking about kids earlier, you teach your kid to read a map, what's in the bottom right corner of every map? A legend or a key. If I have some weird symbol and I don't know how to properly interpret it, that, my friends, in the right corner is a really cool watercolor picture to you. Instead of that's an actual refinery with gas leaking out the top through an optical gas imaging camera, and that color is corresponded to a specific temperature or value. Do you know what that value is? Nope, but it's blue. That's not going to help the person who's saying, where's my leak in my multi-million-dollar facility? Or where's this about to cause a fire? We want thermal protection in places like these, busy operations, to require these or require detection, because whether you like this or not, you may not realize it, but your house might be within a mile or two of a very dangerous facility. And if they don't have this type of monitoring, by the time you hear about it on the news, you're probably breathing something in your house. So this is why we are pushing for this type of stuff to change. Go ahead, Ryan. So how can this assist us? Those of my firefighter buddies on the call, you've been to this type of fire before. This is not something fun. It's not fun for the fire department, not fun for the police or EMS. It is definitely not fun for the business owner. Countless dollars lost. We were discussing this earlier. We're going to pour how many thousands of gallons of water onto this, and where's it going to go? Into your drains, storm water? Where's that black smoke going? How about the school 3 blocks away? The kids on the playground. All right, so waste management, recycling facilities, scrap metal yards, hazmat operations. How many of you actually have businesses or industries in your first due that do chemical processing, ethylene oxide, they do sterilization of medical equipment? There's tons of industries out there that use stuff that's bad news if it breaks loose or is not controlled. It requires a designated adult to watch over it. That's why you have fire brigades, LDAR teams, and all this stuff. But are they doing their job? And how much can one person really catch? That's why we have to have technology to help us with these things. Okay? And that's where the Fire Rover solution comes in, which we'll talk about in a little bit. So how can this make a difference? This is an example of, Ryan can comment a little bit about this, of a fire that the Fire Rover engaged on. The infrared detector, or the thermal detection of the camera, gives the person on the other end of this a warning. And it's a preset alarm. Ryan, you want to comment on how it does that right there?
Yeah, I mean, I'll get into it a little bit more when I get to it. But yeah,
Okay.
I mean, I think I have this video as well.
It's just
So
a picture.
yeah, I mean, I
Okay.
can talk. I mean, basically from our side of the system, it's, we're looking at a preset, a bunch of different like levels of temperatures. And again, I mean, I think the difference between ours and a lot of these other facilities is that, I mean, it's these are such active facilities, right? You're constantly, have forklifts and other things that are running in and out of the area. So we're getting a ton of false alarms that, from an automation perspective, yes, we do get automated alarms, but we're getting a ton of alarms that we need to monitor all day, watch them, and then obviously verify whether what's going on and understand what's going on in the area.
All right. Let me add to that false alarm thing. Ryan, you just said a word that firefighters hate: false alarms. Any of you who are firefighters on the call will testify to how many fire alarms they run in a day that are not real fires. They are false alarms. They're everything from trouble alarms, supervisory alarms, and they are a waste of the taxpayers' dollars. We're endangering people going down the road for no reason, only to get there to realize it was steam from the shower. There was a duct detector that shouldn't have reported. Your system prevents that, because what can you do? You can say, is that a real alarm? Can't you?
Absolutely.
Right?
Yeah, I mean, and that's really what I mean. When we know it's real and it's verified, then we're making the phone call, to the fire authorities, to the customer, and then obviously, when we have the Fire Rover on scene, we're able to
And that's the difference between an automated system and a person like you on the other end, right?
Yeah, I mean, and honestly, there's no, I mean, because typically I think what you see is you have 24/7 operators that are literally just watching these, but they can only watch 2 or 3 at a time. So I mean,
And they're
that's
probably like me, they're drinking coffee 24/7 too, right?
yeah, and they have to go to the bathroom. So
Yeah. All right. You can roll on to the next one. So these cameras do something that firefighters are not used to. These cameras have different tools and applications, and we won't delve into all of them, but I want you to think about the future of fire protection and fire suppression as a whole, and realize that these cameras can draw a box around a specific area. It's called a box tool or area tool, and measure the minimum, maximum, and average, and give a quantitative report over time. They can literally watch a spot and tell you, today it was this temperature, tomorrow it was this temperature, and produce a report. Why is that valuable to industry? Well, if this machine is only supposed to be 130 degrees, and in January it was 130, in February it was 132, in March it was 136, what's happened to that machine? It's gradually heating and producing an issue. If you watch a video you can pull up on why thermocouples are not as accurate as infrared cameras, you'll find out that a lot of manufacturers relied on thermocouple systems that weren't calibrated properly, and they lost their butt, basically. One lost a $20 million refinery, a furnace, because the thermocouple system said it was fine, but the infrared camera was reading 600 degrees hotter, and had a trained operator who was able to compare it and realize, hey, That's not right. They even brought in a second opinion, and they disregarded his opinion until it burned down. Guess what they don't disregard now? His opinion. So they have both systems. Go ahead, Ryan.
Well, yeah, and I think just to add to that, I mean, I think it's not a set it and forget it, right? I mean, there's when you're looking at a lot of the facilities that we're in, they're either outdoors or indoors. So whether it's spring, whether it's summer, I mean, we were talking to, one of our friends in Canada. I mean, at certain times of the year, we're so low. So like, when you think of a sprinkler system that always has to go off at 180 degrees, right? Well, when you have wind and you're dealing with outside temperatures and all the different pieces, like we're constantly looking at our customers and readjusting based on those, depending on what season it is and, other factors that are going into it.
And that's a good point, because from a firefighting perspective, my buddy Scott, who's from Canada, in March, and Canada's, negative 20 something degrees, where here it's about 50 degrees. That's a big difference in context, in their homes, the environment, how the camera's going to perform, the atmospheric attenuation between you and the target, like wind, rain, solar loading, all of those things make a difference. And that's why it takes a trained operator to run it. So a lot of the times in the past, they use things called thermocouple systems, which those of my fire buddies on the call have probably read their share of UL fire reports and read research reports where it shows thermocouple data. And they always base thermocouple data as being the better one. Well, I hate to break it to you, but thermocouples are two pieces of metal, of dissimilar types of metals hooked together in one spot. That's all it's measuring, one spot. And they'll put 6 or 7 of those in a room and tell you that was the absolute truth. Whereas a thermal imaging camera, like the one that's watching on the Fire Rover, has 76,800 points of measurement. Now, I'm no mathematician, but 76,800 is more than 6 or 8 thermocouples, and it may have some room for error depending on who's watching it and what we're looking at, but that's a better measurement and a better tool that can be calibrated from a distance without having to go in and touch the machine. So those IR measurements are actually better now than they used to be, because the pixels are smaller. We're looking at as small as 10 micron now on some of these. A micron is a millionth of a meter, okay? That's smaller than a gnat fart, okay? We're talking really, really tiny. So when we're looking at these things, those measurements are pinpoint. So why are we not trusting and using thermal imaging cameras? I'm not really sure yet, other than what Ryan and I talked about earlier. A lot of people don't want to be the first ones, or they're scared of what they don't know. And they look at the overall cost and they say, well, that's too much. I'm like, well, what's the cost when you lose your business? A lot more. Go ahead, Ryan.
Yeah, I mean, and again, I'll get into some of the preventive maintenance, but yeah, I mean, it's a great point, right? I mean, you have an on-off switch, at a certain points in your process versus looking at it from a macro view.
Mm-hmm. So what's the cost of not monitoring a site like this? Those of you on the call who've responded to a fire like this, how long is the fire department going to be managing this? And I was talking to Ryan about this earlier. Some of these places that are in the middle of nowhere and have a rural department or a minimal staff department or only 2 or 3 stations, you just took out the entire fire protection for the town to manage this one site. Does that mean Mrs. Smith's house down the street doesn't get fire protection that day? Who's moving up and taking care of that? What's the environmental impact of this? How many thousands upon thousand gallons of water is your water system or your water department dumping into this to put it out? Where's that bill go? A lot of times it's just passed on to me and you, the homeowner, the taxpayer. So all of these things make a difference. And I think we should start holding the businesses accountable by saying, if you're going to deal with a hazardous type business, you should have the ability to stop it from becoming a conflagration. Because if you don't, you're basically putting that risk back on the citizen, the taxpayer, and whatever neighborhood or school is close by. I'm not against anybody having a business. I'm a capitalist. But we need to make sure that that doesn't get to that point. And the way we do that is through condition monitoring or thermal detection, along with a trained operator that says, Mongo see heat. We're going to put water on it. Okay, that's a fireman speak, but it's plain and simple as seeing the heat, seeing the problem before it's a bigger problem, right? And if you want to have a really good discussion about this, go get a cheap thermal imaging camera. Ryan and I were talking about this earlier about his wife's into design. Let your spouse walk around the house and look at windows and doors. You will suddenly realize where all your money's going, where your insulation isn't. Don't let her have that camera. Just saying. Next, go ahead. So What's the environmental impact? This is a fire at a Phoenix oil recycling plant. All your oil you dump when you're done, this thing is huge. So you and I get in trouble for a 5-gallon spill of gasoline. How much is that going to cost us, the taxpayer? You think that industry, that one business is going to pay that fine? What's it doing to the quality of the air? Those of us right now with the COVID-19 stuff, everybody's sensitive to respiratory stuff. What about people who are already sensitive to it, asthmatics and COPD and people who already had respiratory issues? If that's right down the home from a very established nursing home community, you're going to have about 35 difficulty breathing calls in the next 20 minutes. That's downwind. That's no good. Whose fault is that? If a condition monitoring system's in place, such as what we're going to discuss, we can prevent that because it'll go from a small fire to no fire instead of this incident. And we don't want to let it get this big, right? Go ahead, brother. So those of you who are hazmagicians, my favorite people in the world, because I am not a hazardous material expert, I have purposely strayed away from two things, active shooter stuff and hazardous materials, because I thought we risked enough, but I have the greatest respect for you. When we look at big businesses that have these types of tanks, this is a tank farm, okay? This has either aviation fuel or gasoline in it. What should they already have in place in these containers or buildings to protect it? Some of them have large scale foam systems with heat detection systems on site. And by the way, a lot of them are not monitored. We had a system at Charlotte Douglas International that a trucker pulls in to load his truck full of fuel. And this is, Ryan, you'll appreciate this. This is the value of having somebody on the other end. And they had a heat detector that would discharge all this foam if it picked up a certain measurement. Well, the truck regen, those of you who drive trucks know what a regen is. It's burning off all that carbon. And when it regens, it reached 1,000 degrees. Well, the Motiva system said, oh, 1,000 degrees, discharge foam. There goes $1 million worth of foam because the trucker was regenning his system while he was filling up. That's not good. That's a waste. Now we got to get that foam back in, the environmental impact. That's why you need somebody watching it. Waste sites, landfills, everybody's had to take something to the landfill. How many of you have been to a landfill fire? How long is that going to burn? Days, weeks, months even. Mine fires, all those things require oversight. Those of you who have boilers or incinerators, the thermal imaging industry has a camera now that they can stick a metal tube inside of a furnace, hit a button, it filters the flames out so they can inspect the tubes of the furnace while it's operating at 3,000 degrees. That's pretty neat. And all we're doing with them is pointing around going, that's hot, that's not. You can do a lot more with these things than people have ever imagined. And I can tell you, after taking about 20 grand worth of thermal imaging certifications, every time I go through a class, I feel like a caveman holding a flashlight, realizing the rest of the world is light years ahead of us. And we need to catch up with this and understand we can monitor things and prevent bad things from happening, which is the whole purpose of fire, EMS, and police from one of these things going off. Because I promise you, you don't want to go to a tank farm fire. Go ahead, Ryan.
Yeah, and I mean, I think, you make a good point, right? And I think one of the things, it's like, does every business now need to become an expert on this? And the answer isn't yes, right? Like, I mean, just like, I don't want to go out and learn how to build a car. Could I theoretically do that? Sure, but what's my business, right? The business is the hazardous materials, the waste, the other things that they're dealing with. And they're not just dealing with fire and waste and recycling, right? I mean, we're dealing with deaths to garbage, to some of the garbage collectors, right? Because people don't slow down to get around and all the different things that are happening. So, again, I think it is. It's like we're at that evolution stage where a lot of our customers have tried to do this, right? And like basically, my thing is that you leave this to your expertise, and most of those customers are now customers as opposed to guys who had done it before. So I'll definitely you know I definitely appreciate what you're saying as far as how difficult it really is to use these, and like what the secret sauce really is for the solution that we're putting together.
Well, I'm glad you said difficult, because the next acronym is a good example of that. LDAR, which I learned when I started going through thermography school, stands for Leak Detection and Repair Teams. These individuals work at places like refineries where they monitor between 500 to 700 points a day. And those points are couplings, threads, valves, exhaust, anywhere something could leak that's not only going to cause a problem, but it's going to cost them money. Those who work in optical gas imaging will go, fly out, drive out, take their camera, and find a small leak on Shell Oil's rig out in the middle of the ocean, and that may save them $250,000 a year. That's a big deal. So those are already in existence. But the problem with LDAR teams is human error. One of the reports I read said an employee documented that he checked 6,000 points in one day. That averaged out to him measuring a point every 3.6 seconds. Now, I know a lot of your kids are probably good at video games, but nobody's that good. Okay, that's a computerized system. There's heat activated suppression systems, like I mentioned earlier, for the tank farm fires and more. We were talking about overseas. A lot of the overseas tank farms have these clamp-on giant nozzles like what the Fire Rover has, but bigger. And they're already set there, pointed at the target. There's IR camera monitoring. IR stands for infrared or thermal, which all we're doing is looking for remote problems that may occur. And then there's the optical gas imaging, which is very specialized, very highly trained. You don't just take it out of the box, plug and play. And this is, I got a brand new iPhone in 20 minutes. I know what I'm doing. No, it's not that way. Trust me. I've been doing it for 10 years and I still feel like every time I get something, I'm like, wow, what does this do? How's this work? What do I need to learn? Because we owe it to the customer, the citizen, and the person we're training to know as much as we can know. We can't know everything, but as much as we possibly can know so they can do a better job protecting their business, the citizen, and everyone else. Go ahead, Ryan. So in summary, one of the things you'll figure out is thermal detection is everywhere. If you don't believe me, read about 5G and what they're doing. 5G will have these little things everywhere, and they will have monitors with them to make sure they're working. You'll notice them in hospitals. In our recent tour we took yesterday in the American Express Black Card Members Lounge, very expensive little lounge in the airport. They had these FLIR cameras in there pointed at every heat source in that lounge, doing what basically similar to what the Fire Rover is doing, Ryan. But they were saying, is that a problem? Don't activate the sprinkler system because we don't want to flood our $1 million kitchen, right? They're using industry, fire, EMS, and police. I gave you examples. There's a fire use camera in the middle, and they've become big hobby use. You can buy something like the FLIR One or a CAT thermal imaging camera. There's a new one out now for $500 by Blackview. All of them are integrated in your cell phone. Now, those are very low resolution hobby cameras. They're not, don't buy one and go take it in the fire. Your iPhone, once it reaches about 120 degrees, the buttons won't work anyway. It'll say, iPhone is too hot for use. You'll see the little thermometer. It's not designed for that. So like we talk about, each one is designed for a specific solution or context. You get them big money in security and military. If you hadn't figured it out, thermal imaging was military grade technology. Always has been, always will. There's a reason why you can't get a infrared camera or thermal camera above 9 hertz and take it out of this country. Because outside of US and Canada, if it's above 9 hertz, you violate a law called ITAR, International Trades and Arms Regulation Law. So in order for you to take it there, you got to have paperwork, certifications, letter of intent, because you don't want a bad guy with one of those cameras watching your family. And as Ryan will talk about here in a minute, waste management and recycling, it's big business because they have a lot to lose if these things catch on fire. That's why we need it. Go ahead, sir. So what thermal protections are in place that you weren't aware of? Like that's the system we just bought for our house. It's like $600, I think. How can businesses reduce loss and improve efficiency using thermal condition monitoring? And what did we change or spark any paradigm changes in your mind or about what you're going to do differently after this? And I want you to think about that as Ryan leads us through what's going on in the industrial world and the recycling world with the solution called Fire Rover and why I think it's a pretty neat solution you should check out. And any firefighter likes to flow water, so you got our attention because you're putting water on the fire right now. So you got our attention. Ryan, take it away.
No, I appreciate it. And again, I mean, I think, for the guys that are here that are from your side from a training perspective, I mean, I appreciate it. I mean, I'll keep it. I know we have a hard stop theoretically at 1. But just to kind of go through what we're dealing with in waste and recycling. I mean, we've had an increase in fires over the last few years, and really, to keep it at a high level. I mean, we've always had traditional hazards. We've had a ton of hazards for years: aerosol cans, butane cans, and pool chemicals, those types of things. But there's really been an onslaught of lithium-ion batteries that have hit the industry. And again, I've been reporting the reported fires for waste and recycling facilities since 2016. It's an ongoing effort, and we're basically seeing that, 2/3 of most, or 86%, according to California Product Stewardess Council, that have had a fire in the facility in the last 2 years. I mean, there's been an inherent risk of fire for years and years in the industry. And again, one of the reasons I show this slide is that, in Europe, there was a survey done, and they had said, okay, if I am down, and I do have a fire. Typically, 75% of those that had a fire are down for more than, or 75% are down for more than a day, right? So, again, most importantly, we want to protect our employees. We want to protect the safety of our fire professionals. Secondly, we want to protect our building and our equipment. And third, most importantly, or third most important, would be continuity of business. And so when you have when you have an issue, and I know, Andy, you're dealing with a lot of these where they actually still require you to use fluorine foam, but you have cleanup and all the different things that go with it. So what we've tried to develop is a solution that is easy to work, easy to clean, doesn't have any environmental effects, and allows our customer, obviously, safety of life and injury, but most importantly, after those, to go back to work. So this was the same survey. Over half of the fires that were reported since 2008, these were due to battery fires. So I did a LinkedIn post of a 9-volt battery with a little bit of steel wool, and that's like literally it lights it in seconds, right? So again, there's just so many things that can go on, and we need to be very diligent from a waste and recycling perspective what we're putting in our curbside bins. I think one of my contacts will tell me that we literally create bombs in our curbside bins, and we're not doing it deliberately, but we're going in, and we're using paint thinner and rags and other things, and we're throwing them into a one of these hefty bags. We close it as tight as possible. We throw it in our curbside bin. It's 100 degrees outside. Your bin becomes about 120, 130 degrees, and then that gets thrown into a garbage truck, which basically is putting pressure on it. If there's anything around it that can cause a spark, that thing will literally explode. So we do see a ton of fires in our trucks, and then we're also seeing them being dumped on tip floors, from whether they were a hot load before or whether, they weren't. And I think a lithium ion battery perspective, the most important thing to look at is that, most lithium ion batteries are very safe technology, right? And again, I know Ron's on the phone, I'm sure he's smiling, but really when you think through it, right, like the lithium ion battery is mostly fine up until we start to treat it with harsh gloves, right? So, and with waste and recycling, we're doing nothing but beating these things up. So, when I get into scope of problem, I mean, we've definitely had fires for years. I think, the thing that I find interesting is that, we see a ton of these waste and recycling fires, and we're putting out a ton of fires. I mean, we put out 200 over the past year in our clients' facilities. And as we continue to do that, we're hoping to see the number of these fires go down. But really,
Ryan, the firefighters on the call. Ryan just said they put out 200 fires in a year. 200. How many of y'all get to go to 200 fires in a year? And you play on the Xbox, we can play on this and put out real fire. That's a cool job.
absolutely. And it's funny. I mean, my first, my first expo that we went to, it was the fire show. I'm trying to remember the name. It's the Fire Expo in Indianapolis.
FDIC.
Yeah,
Yes.
FDIC. So we were there, and everyone was like, "Don't you think you're going to make the fire? The fire guys are getting mad at you because you're trying to put them out of a job." And I'm like, "The last thing we're trying to do is put a firefighter out of a job, right? I mean, these are the fires you guys don't want to fight. Period, right? You don't want to go into a scrap metal facility that has, 4 different piles, or a waste and recycling facility, or a hazard material facility. You have to fight a fire when we can hopefully, put it out before it happens." Um, so again, let me get into. I mean, this COVID effect, I think, is an interesting thing that we're seeing, and this is one of the numbers that I'm pulling out of basically March, April, and May of this year. We've seen an increase in waste, paper, and plastic fires due to a couple of factors, but I think it's the 100-year spring cleanout, right, where we've all been stuck at home and we've been cleaning out our buildings or our houses, and we're pulling out a ton of lithium-ion batteries that have been in the attic for 5 years or in the basement for 5 years, and we're pulling them out, and where do we throw them? Everything goes into that receptacle, or the recycling receptacle, or to a waste receptacle. So really, the one thing I will say, we need to be as diligent as possible, but we are dealing with an increase in risks over these last few months. Um, Again, this is reported fires. I mean, unfortunately, these aren't typically injuries to employees. Typically, these are to firefighters. Where they're fighting, in a 98-degree fire, they're fighting for 45 minutes. They're getting washed and cleaned and cooled down, and then going back in and basically fighting that fire again. So, again, I understand from an industry perspective, the number of injuries is a big deal, whether it's happening from employees or from the firefighters who are forced to fight these fires. Um, Again, from an insurance perspective, I think that's always the question that we get. What's happening from an insurance perspective, and insurers are moving I mean, they've been leaving at a crazy rate. I think this was 2018 was really that watershed moment where they realized that, like, if you're looking at shredder claims have gone up, lithium ion battery claims have gone up, and um, you know, those were all due to actual claims from the top five insurers that have exited the market. So I know I spend a ton of time working with companies that have specific programs, and I've literally this week alone, I had 3 calls with 3 different programs where, they're trying to get back into the industry, but at the end of the day, they're only going to go after the best operators who are putting in and investing in the right processes, the right operations, and the right investment in technology to ensure that they don't have these fires. And one of the things I think a lot of people will learn, like, if you're in this industry and you're looking for insurance, if you want your fleet insured, you have a better shot of getting your fleet insured with a property. But they're not just doing the property anymore. They're not just writing the property because they get the fleet like they used to. They're really looking at the hazards of the facility, and they're not checking the box anymore. So I think a lot of our customers have come to us, desperate, right? I mean, they need insurance, and they want to make sure it's at a pretty good premium. And as I when I talk to a lot of these insurers, it doesn't make sense for them to charge so much that we can't afford to be in business, because obviously that's not good for anyone in the industry. So really, the idea is to mitigate that risk over time and do everything we can to try to make it more safe within the expectations of that we're dealing with. So, and again, I fought this for years, right? Like, that if there was a fire, it was always looked at the operations guy, the fire professional, the safety guy, and say what went wrong. And I mean, one of my customers, they always would say that they would never have a fire because of all their fire employees have military backgrounds, and guess what? They lost 2 of their biggest facilities. So, it's one of those things where there is an inherent risk of fire in our daily operations. And I'll tell you, that's really the thing that ties all of our businesses, whether it's hazard material, waste, recycling, rubber, and any of the others. There is an inherent risk of fire, in our operations. And what can you do? And again, preparing your fire safety plan. I mean, I'm not going to get into this, but, this is something where most importantly, you need a plan: fire prevention, evacuation, and emergency response. I do have some options that Jim Emerson and I have put together for waste and recycling facility, but I'm going to run through those just based on time. So really, what we do uniquely as in our system is that it's your job as your employer and as an employee and an operator to prevent fires, to do everything you possibly can to prevent that fire. It's the professional response to do everything they can to protect you. Now, again, you as an operator need to work with your fire department and your local operators to ensure that you guys are doing everything you can. They know how to get in your building after hours. They know how to unlock your fences. They know where the material is. The more you work with your professional response, the better chance you have of them feeling comfortable fighting a fire. But with most importantly, from our perspective as Fire Rover, and from my perspective as we believe that the internal response is where the greatest opportunity lies to really change the game. I know Wish is an organization in Europe, and they basically said if there's a fire in a waste and recycling facility, they defined a successful outcome as having the fire put out and under control within 4 hours of a fire starting in a facility. I believe that unless if we don't have it out or under control before the fire department arrives on scene, then we failed, right? And again, when I say failed, of course, it's a definition of what is a failure. If we can get this out and you're back to business, if we can get this out and you save your building, if we can get these out, and most of the time we have these fires out before the fire department will arrive on scene, and that is a successful outcome. Now, we've had a couple, and I'll show you that where we work and partner with the fire department to put these out, but again, most of the work that's going to provide that successful outcome is done within the first 10 minutes of a fire being detected and actually suppressed. So again, what we're trying to do is number one, focus on those 10 minutes, but we're also trying to set the tripwire earlier in the process as possible. So as Andy had said before, when you're looking at it, I'm looking at thermal trends. I'm trying to understand, is there a rubber feedstock? Is there a deep-seated fire that's sitting in a rubber feedstock pile that I can catch today before it opens and I have a 7-day fire and a massive fire that I'm dealing with? Or with ASR piles for scrap metal, where we're watching these and we're actually putting out hotspots and we're constantly doing it, as part of the operation. Really, our goal is do not have a major fire. Do not have one of those fires that Andy showed that has 7 alarms, that uses up every resource, that uses 1 million gallons of water. And we've all heard the horror stories, and most of the reported fires that I'm reporting, or the ones that I'm showing from, or that are included in my data, they're actually from the 2 alarm, 3 alarm, 5 alarm, 7 alarm fires, right? The 1, 2, the ones that are being caught relatively easy, those aren't being reported. So what we do is we utilize thermal detection. Again, this is, thank you, Andy, for really getting into what we're doing, but we use the top grade thermal technology from FLIR. We're agnostic on what we do use, but we automate and we see what's going on, and then we're trending that heat. And when we see an abnormality, we look at it from our UL certified facilities. We're in 4 different states. We have a ton of butts and seats, and we're looking at it and we're basically saying, okay, is there a fire? Now let's look at that and say, or is there an alarm? Is that alarm a real fire? And we have human verification. Again, it's not an automated solution. It's automated to certain points, and then there's a human intervention that will look at it and basically detect and verify. That verification being the main piece, and then they are able to do a few things. One, they can call the fire department, the fire authorities that are on scene. They can call the jet, or that will come on scene. They can call our operator and our client, or text our operator and our client, and then they can start our unit, which we have a Fire Rover unit on site at most of our facilities. And again, I'll get into the different solutions in a second. But really, we have a Fire Rover box. It's a 20 by 8 by 8 container. It's heated, it's cooled. So beauty is it can be in Canada and it can be in the desert. I get asked that question all the time. We have a heartbeat with the system, so we know what temperature, we know every single component in here. We know whether or not it's failing or if it's working at any time. And so if you look from an outdoor perspective, you'll typically have a 22-foot mast, 2 cameras, and a nozzle. All it needs is internet and electricity. An indoor operation, we do custom plumb of everything, and it's a dry system, so there's never actually product that is inside the pipes. And if it is, once we are completed, we'll purge the lines. And again, all you're going to see in your facility are 2 cameras and a nozzle, inside your 40-foot or 50-foot ceiling, and that's going to allow us to cover about 140 feet each way, so about 280 feet by 140 feet. Depending whether it's indoors and outdoors, and there's a lot of things that come with that. But the idea is that when we see a fire, our agent now charges our unit. There's a 1,000-gallon tank. It has 3% of our environmentally friendly cooling agent, and we're able to literally shoot and cool the hotspot. Whether it's the middle of the night, whether there's smoke, whether there's anything that's happening, we're able to fight that fire. So these are kind of all the basics. And again, I will send this out. I want to get into this. I mean, there's really 4 solutions that we've evolved into. One is the thermal only solution, where we utilize our thermal cameras, and then basically we utilize our thermal cameras in our detection and our monitoring, and then you as a customer are putting that fire out yourself with a fire brigade, or you're calling the professionals when there, or we're calling the professionals when there's a fire. We have the Fire Rover solution, which is our traditional solution that I just showed you, but basically it's got a limited amount of water that it can shoot. Typically shoots about 8 to 12 minutes, and again, it's a lot of material when we catch them as early as we can. And there's a rubber feedstock video that I'll show where we literally had a 3,000-degree rubber feedstock fire out within 4.5 minutes and used like about half the tank. But that's one. Now we have the Fire Rover sprinkler replacement, and what this is that we've actually we've done this for a couple of lithium-ion battery facilities and a number of MRFs where we have the Fire Rover boxes that are covering the entire area, the Fire Rover cameras and boxes, and then we have a manifold that is a quick connect to the fire department. So when they get to on scene, if we still have a fire, instead of going in and taking a proactive approach or an offensive approach, they're able to take a defensive approach and do a quick connect to our manifold, and then we can shoot for 40 to 50 minutes based on the amount of water that they have access to. So again, this is we just got our first variants at a MRF that we're building in Michigan. So now it is Fire Rover in lieu of sprinkler system. We have one in Indiana that's a 350,000 square foot facility that we did and got approval for, and then we just finished a large lithium-ion battery operation as well. So I mean we have about 10 of these where the Fire Rover is a sprinkler system with this with this additional solution, and then we've developed the Fire Rover deluge system, and this is for waste to energy facilities. And the idea with this is that we're not utilizing our boxes at all. We have cameras and nozzles, and we are utilizing the existing infrastructure and the existing pressure and the existing water infrastructure that was used in the past for sprinkler systems. And so we connect our nozzles and our cameras. We're doing detection, and when we do see an abnormality, instead of pressing a deluge system that'll drop 20,000 gallons of water, we are doing a focused and targeted deluge system where we're shooting just water onto these facilities where you're dealing with a ton and ton of material that really just needs as much water as you can put on it. So I mean, this is and I should say all these videos are available at our YouTube page, and I can get into it. I know in lack of time, let me just show a couple of them. But this is our Fire Rover system in action. There is a joystick on our desks of our agents. This is an outdoor facility where we're shooting about, this is 10, typically this is a further, 22 foot, but we can shoot this about 145 feet when they're outdoors and they're coming straight out of coming straight out of the box. The closer we are to the box, obviously, the further we can shoot. And then some of these new solutions that we have, we're using larger monitors. And if we have the water pressure, we're able to shoot, up to 200, 250 feet with some of our new solutions. So as you can see, that's how far it's really shooting. And again, anyone who wants to stay on, I'll go for another 5 minutes if that's okay. This is a tipping floor fire elimination video. So basically, when you think through this, the big issue that we see is that a lot of these facilities, even though they have high ceilings, they fill with smoke. And one of my biggest pet peeves is like a fire extinguisher was only meant for you to escape a burning building. It's not made for you to go fight a lithium-ion battery fire. And again, I know it's in the rules, I understand it, but so in this situation specifically, we're cooling this specific fire, and again, this is a human being who's controlling this and moving the joystick as they see it. And again, you can see in here, there's a couple different.
Ryan,
they go. Yep.
That video you just showed is really important from a firefighter perspective because the first part you show a nozzle flowing into a big smoke cloud. Without that thermal imaging camera, you wouldn't be able to pinpoint exactly where that water needed to be able to go. And
absolutely.
That's what we teach. That's what we teach in our curriculum too. That's an enhanced string placement, or as you called it, a surgical strike. I like that. You're putting it where it needs to go.
Well, yeah, and I think, I mean, a lot of our a lot of our customers, what they'll do, I mean, they think they have time. So, there was a waste to energy facility that they had water monitors, and they were basically manual water monitors, and they always had a disaster plan where they would run over and they would point the monitors in the direction of the location, and then they would evacuate. Well, they had a fire. This was in Florida, a huge fire that happened. It was about 8 years ago, and they didn't have any time. I mean, these were 70-foot ceilings, right? Because you're dealing with basically 7 floors of trash, and and they didn't have any time whatsoever. They didn't even have a minute and a half. This is from the general manager that we talked to. So it's really one of those things that if you're fighting these fires, I mean, you got to make sure that you can see through the smoke and you're being safe about doing that, right? This is actually preventative maintenance, so I think this is an important one to show. When you were talking about, is there heat at one specific point versus looking at a macro view of an area, and how much, how much, um, how much heat is actually happening across the board, right? So, like here, we have a thermal camera strategically located onto the infeed. When there's a fire, we shut down all conveyors in this operation, and we do this for a number of our MRF and transfer station. So, mostly our MRFs, but basically the idea is that when we see these, we can actually go and we can fight a fire, um, and but most importantly, the fire is not moving. Now, what you're seeing here is you're actually seeing fire extinguishers. So these were, two of the employees put fire extinguishers in, and again, they are too close. I mean, they're right here. They're too close, and they're really stopping us from shooting our fire, the Fire Rover nozzle at the time. So you'll see as they get off, this is where you'll start to see the Fire Rover start to shoot. You know, um, and again, in interest of time, I'll just kind of show. I mean, this we had it out in about 45 seconds, but had we been able to just go at it from the very beginning, we would have been in good shape. This one actually just happened a couple weeks ago, and I like to show this because I think it's really important to understand that you know one of the things is that this was in the typical operations of our fire department or of our of a tip floor, right? This was a C&D location, and you see this. I mean, there's some sort of accelerant that was in here. They were doing nothing wrong from a loading perspective. So one of the things that Jim Emerson and I have been trying to push to everybody in the industry is that if you have a fire and it's a deep-seated fire inside of a tip floor, what you want to do is make sure that you pre-wet it before you take your loader and try to move the fire out. Now again, 5 out of 10 times, 8 out of 10 times, you're grabbing that lithium-ion battery, you're bringing it out, and it can work for you. But those times that it doesn't happen, you're better off pre-wetting the area with our wetting foam, and then going in and trying to pull away layers to really get to the deep-seated fire. In this case, you can watch this again. I mean, this had nothing to do with these guys were literally just pushing the loader right in. And as you can see, I mean, this was an eruption of fire. Now, within 4.5 minutes, I mean, we went after this, and we'll start shooting at it. And again, it's so many different areas. We're going after the fire department, got on scene relatively quickly. But we did have the fire. We had all of the hot spots. And again, this is one of the things that Andy will talk about is that just because this looks like it's a fire doesn't mean that it's hot. And the reason I say that is when I get into, sorry that this is being covered here, but again, we're still shooting in the smoke. We still see the areas that we're shooting at. And here you'll start to get to, like right in here, it still looks like there's a fire, but you're seeing as it starts to come down, you'll see little temperature gauges as this goes away. Now, again, of course, there's hot spots, but whether there's flames or not, it looks like it is, but I mean, it's not actually flames in this case. And again, we'll continue to go at it until this thing was out. Um, and again, our customers were back to work the next day, so I mean, I would say that this is probably one of the worst that we've seen. I mean, a lot of times what we're going to see is just a lithium ion battery fire in a tip floor. We see this, it's after hours, you know, we go, we shoot it, we put it out. I mean, most of the time we shoot for 20 seconds, 30 seconds, and we have a fire put out, right? You know, our operator didn't know about this. They don't even know about it because, again, we had this thing out. We had we sent them a video the next day and said, hey, your fire was taken care of. And again, the beauty of our system is that we have built-in Firewatch. We're we're still watching it, and we still had 98% of our tank there ready to fight it if we needed to. So
Hey Ryan,
it's typical
you,
with
you
like
just got like
go ahead,
you
Andy.
just got big brownie points from all the firefighters. You know why?
I don't know.
You said a word that we all hate, fire watch. That means the fire's out, the fun's over, and we sit in a truck and once an hour get out and go look at it. So you just made a bunch of people happy by saying, "Oh, you guys can go home. We got this."
Well, and this
Because
one,
that's
I
huge.
agree, right? They'll make you stand there for 3 days as you sit and watch a fire, which you can't control, right? But this one I like to
Mhm.
show because honestly, from a firefighter perspective, if you've ever fought a rubber fire, I mean, they're a freaking nightmare, right? So this was a rubber feedstock fire for one of ours. We had it out in 4.5 minutes before the fire department was able to arrive on scene. We protect the building with a our environmental friendly like cooling foam, and this I mean wetting agent. It's an encapsulator agent that we're using. But again, the idea is that literally we work away at this, and before the firefighters are on scene, this is out, and we're doing firewall, right? We still have 40% left of our tank, which I mean this is unheard of. When I show people this, they honestly like most firefighters are like, oh man, like they always have, the horror stories of fighting one of these for days. So with that, I mean, in an interest of time, I mean, I do have a ton of different videos. I mean, this is our hazard material, one of our hazard material customers. That again, what we're doing is a little different. We're fighting the actual, or we're actually ensuring that their operations stay within an existing temperature range, right? So it's more of a once we see that it goes out of range, we're there to back them up when there's a fire. I think one of the things that you'll see here is that like we're used to dust and dirt, and we come on site, we clean the our lenses as we need to. We know what's going on at all times. So again, it's like there isn't a place that's too cold, too hot, too dirty, um, you know, too much vibration. I mean that's all part of our solution. So, um, but what I will do, the one last thing I'd like to show you guys, and again, I'll send this video out, but like the fire brigade tools, because honestly, my biggest pet peeve is standard fire sprinkler system or standard fire extinguishers. These are a 10 and we sell threes, and this is a 60. These can shoot 90 feet away, and it's environmentally friendly. You can actually shoot the product, and you're at least from a far enough distance away so that maybe you're standing outside and you can shoot inside towards the tip floor. Or this is also great for the fire department when they arrive on scene, as they're setting up and laying out their hoses and doing all the different things that they're trying to do. Some one of their guys can go in and basically with two quick turns they're shooting for 4 to 6 minutes, and they have some significant power at it. So this is part of our do-it-yourself solution. Again, that's probably the wrong term when we say do it yourself. Do you want to, have a fire brigade? That's an insurance question and a business question. But really, at the end of the day, there are better tools out there, and they're reasonably priced, right? So it's not to say that they you know at the very least, if you're going to force your customers or your employees, and I should use the wrong term, but if you're going to allow your employees to fight these fires, let's make sure that they have the right tool in their tool belt. So with that, I mean, my information's here. I know, Andy. I mean, if you want to wrap up a bit, I know you do some trainings and other things, so definitely want to allow you to share that with the group. But I appreciate everybody for coming, and if you have questions and you want to stay on, we're more than happy to. And sorry that this one took a little bit longer than normal.
Thank you, Ryan, for the opportunity, and thank you for the work you've been doing. I've been following you guys probably since I first saw y'all come online, so it's been pretty cool to get to know you and see what you're doing. Those of you who've taken some of our classes before know that we offer a lot of other resources. A lot of them are free. You can join our tactical thermal imaging group, where I will post highlights of this. He will post this on YouTube. Our blog, we will post topics, and we still post topics, short articles. We're going to put the article that Ryan and I shared on Waste 360 on there as well. Our YouTube channel has over 400 videos, and thanks to Fire Rover, we'll have some more I will be adding. Ryan, I've also created a Fire Rover highlights reel of some of y'all's videos and put them together and put some cool rock music behind it for the firefighting crowd. So I'm going to share that on our tactical thermal imaging page. And if any of you are interested, you can watch webinars like these pre-recorded for as much as you want or as little as you want for 20 bucks a month on our Patreon site. And as Scott and several of you know, we do a lot of webinars, a lot of free ones, a lot of some are low cost, but bottom line is we want you to get the training information out there so you can be an educated user. Don't just believe the hype. Go and do your homework, get as much information as you can. Call me, call Ryan, whoever will answer your question. We want you to benefit from this. It doesn't do any good for you to buy something and not know how to use it. Whether it's something as small as a handheld thermal imaging camera, as big as a Fire Rover system, we all need to be educated. And that's the goal, is that we be educated, make a difference in what we do. And from a firefighter all the way up to the Fire Rover system, we're all out for the same mission, which is to serve and protect and save lives and property. So thank you for your time, Ryan. Appreciate the opportunity. If anybody has any questions, we're here for you.
Yeah, no, it sounds good. Thanks, Andy. Anybody have any questions? I mean, I'll open it up. Anyone want to email us questions? Feel free as well. And thank you guys all for joining. And,
thank you guys very much for putting in the time. I got to take off, but very good presentation.
No, we appreciate it. Thanks, Scott. We appreciate you joining.
No problem.
Thanks, Scott.
All right, thanks everybody. I'm sure we'll get some emails. So yeah, Andy, thanks. I appreciate it again. And let's touch base later, and I'll send you the recording of this as well.
Thank you so much, Ryan, for the opportunity, and appreciate what you do.
All right, thanks. You too.